Today we're going to be talking about sampling and bias. All right, so the next couple of lectures, they're really going to be about the way that you collect the data and the different ways that are involved there. And it's really because we're going to be going into inferential statistics. So we're going to be talking about sort of the difference between descriptive statistics and inferential statistics. And in that introduction, we're first going to start off with, okay, how do you collect the data in order to do inferential statistics? And so because of that, we're going to be talking about how these two methods are involved: sampling to collect data and experiments to collect data. And then the bulk of this lecture is going to be based on sampling. It's going to be about why we use sampling, the goal of sampling, which is to avoid bias, and the types of biases that might occur because of different kinds of sampling. All right, so first let's start off with the difference between descriptive statistics and inferential statistics. Although you may not have noticed so far, what we've been doing is largely descriptive statistics. So everything that we've been doing so far, like visualizing data, summarizing data, getting things like the mean, median, interquartile range, standard deviation, right? All of those things are just about summarizing that data. And we've looked at doing that for one variable or two variables, right? So we've looked at getting mean, median, and mode and visualizing one variable at a time on bar graphs or histograms. But we've also looked at things like regression and correlation and looking at scatter plots. So visualizing and summarizing two variables at a time. But even though we can do all of that stuff so far, there are still lots of things we can't do that are really obviously sort of important. So here's one example. So right now we could do stuff like this. A sample of 53 out of 100 voters will vote for candidate A. But here's what we don't know. Will candidate A win the election? How likely is that? I don't know, right? So it's like, so far we could summarize our sample, we could visualize it, but we can't make any conclusions about it for the actual population. So this is, we can't do generalization yet. So this is what this sort of skill or ability is called. We can't do generalization going from the sample to understand something about the population. So that's something we cannot do yet. All right, so here's another example of something we can't do. So a sample of 20 preschoolers who are raised with pets scored an average of 5.6 out of 10 on a biology quiz, but a sample of those without pets scored 4.5. Does this mean that having pets make children better at biology? Well, we have no idea. I could tell you, I could summarize for you the sample of 20 preschoolers with pets and without pets. I could summarize that. I could visualize that for you. And I could do that for these two variables, whether they've been raised with pets or not. So the pets variable, which is categorical, and their score on the biology test, which is continuous. So I could do that. But I still can't tell you whether having pets actually cause children to be better at biology. So this is compare and find causation. Compare and causation. So we cannot figure out causation so far. And that's really going from the data in order to have a theory about causation, right? And so this is something that we're also not able to do. So number one thing we can't do any generalization. Number two thing we can't do is we can't say anything about one variable causing another variable, causing changes in another variable. All right, so first, in order to tackle generalization, that's why we're going to take on sampling. So sampling is going to help solve this problem. And just as an aside, in order to take on the problem of not being able to determine causation, we're going to be using experiments to do that. So first, let's talk about sampling. All right, so here, this is a common generalization problem. We have the sample where 53 out of 100 voters will vote for candidate A, but the question is, will candidate A win the actual election? So here, our little sample is 100 potential voters, right? So we have these 100 potential voters, and we know what their opinion is like. But the question is, every voter in election, we want to predict their behavior, right? And that's the problem. We only know about these 100 potential voters, which is a subset, and we just don't know if they reflect every voter in the election. And so what we're really looking for is a way to get a sample of this population that actually represents this population well. So, sampling is the method of choosing your sample or the items or cases in your study. Right? So that's the whole idea behind sampling. It's a method of choosing your particular sample. But here's the thing. In order to select a good sample, right? So what is a good sample? A good sample is one that is a representative sample. Representative sample. And by representative, we mean that this sample, if it accurately reflects this population, then that's a really good sample. Now, it's hard to guarantee a good sample because there's just no way I could ever really know from looking at a tiny bit if it actually reflects the population. The only way I could really know that is if I knew everything about the population, then I could compare it to my sample and say, my sample is representative. But that's the exact problem. We often can't, get the whole population. So how do I know if my sample is any good? Well, bad news is you can't really know. But the good news is we determine a good sample by a good sampling method. So it's sort of like this. We're not going to judge your recipe by how good the food actually turns out. We're going to judge the recipe by looking at how good the recipe or the techniques actually are. So in that way, we don't judge the sample by actually knowing how representative it is, but we think it's a good sample if it has a good sampling method. And by good, we mean unbiased. So that's what we're really looking for. Ultimately, our goal is a representative sample, but in order to get there, all we have sort of the tools at our hands is unbiased sampling method. So as long as you have an unbiased sampling method, you're safe as you can be because there's no other way to check whether that sample is actually representative or not. All right, so before we go on, let's take a moment to define samples and populations. So population is the entire universe of cases that you're interested in. Entire set of cases you are interested in. So sometimes populations are manageable. For instance, if your population is all the people in your school, right? So it's a manageable size, right? It's maybe your school has 10,000 people. Even though that's a lot, it's still more manageable, and it's very, very well defined, right? It's easy to say, oh, you're a student, you're not, But Or maybe you have a company and your population is all your employees, right? So that's another sample, or that's another population that's sort of smaller and manageable. But oftentimes populations are quite large and unmanageable and even undefinable. For instance, Coca-Cola might be interested in potential customers, right? It's really hard to say who's a potential customer of Coca-Cola. I mean, they might be as diverse as like a chaiwala from India or like a businessman in New York City, right? So like all those people might be customers of potential customers for Coca-Cola, right? And so the entire set of cases is whatever you're actually interested in. Oftentimes in psychological or sociological or social science studies, the entire cases you're interested in are something like all adolescents or all American adolescents or something like that, or all adults, right? And so those are like some pretty wide-ranging populations that are very, very difficult to define and pinpoint. So it would be impossible to collect data on all of those people. Now, the sample is drawn from that population, so it's a subset of the population. So the sample is a subset of the population. Not only that, but the sample is also the people who are actually in your study, or the cases that are actually in your study, right? And so it doesn't have to be people. For instance, it could be pills made in your factory, right? So you're not going to look at every single pill made in your factory. That would be the population. But maybe you'll take a sample. You'll take one bottle from a case, right? And that will be your sample. And so the sample is the subset that you collect data on. And so these are presumably the ones in your study or data set. All right, so that's the difference between populations and samples. Now, when we collect data from an entire population, mind you, that's very, very rare, but it does sometimes happen, and that's actually called a census. Right? When you collect data from every single case that you are interested in, right? That's very, very thorough. That is often not what we do, right? Here, we sample. We use sampling methods. And here, we collect data on a sample, right?